All right, Algebra 2, Section 1.6 notes, objective, solve linear inequalities. We've done this since Algebra 1. It's just really important that you remember the rules and get those down. Okay, so it says graph x is less than 2. What x is less than 2 means is that we want numbers that are all less than 2. So usually just plot a few numbers. Okay, and remember if it's less than, if the letter's on the left side, the arrow will point to where it's going. You know, x is less than 2, or the alligator or Pac-Man will eat the bigger number. But remember, if it's less than or greater than, it should be an open circle. And if it's equal to, it should be a closed circle. Okay, so this should be an open circle on 2, and then I just draw my line above just so we can see it, but it's going towards all the numbers. That is wrong. Let me go back, do that real quick. Okay, so it should be an open circle on 2 and go into all the numbers less than 2, like 1 and 0 and -1. Okay, so all the numbers less than 2 is where the arrow should be going. Okay, it's another way to think about it. X is greater than or equal to -1 should be, make a number line. We got 0, we got -1, we got -2. Just put as many, just put a few on there. Okay, and we'll start at -1 since it's equal to, it's a closed circle. And since we're looking at all the numbers greater than -1, we're going to go to the right. All the numbers greater than -1 would be 0, 1, 2, and stuff like that. Okay, so just make sure you pick some numbers to the left and to the right of the main number we're trying to find. Okay. Okay, compound inequalities. When the x is in the middle, that means that it has to connect. It has to be less than, or it has to be, this is -1 is less than x, or x is greater than -1. So it has to be numbers bigger than -1 and less than 2. So we're going to plot those numbers. We got to start at 0. Let's go to -1. Let's just plot -2 as well. We'll plot 2. Okay, so then we have -1 on that. We have open circle. Okay, and on 2 we have an open circle. And when the x is in the middle, it's connecting. Okay. So we're looking for numbers that are greater than -1 and less than 2, if you think about in terms of x. Like 0 or 1, those would be numbers that are greater than -1 and less than 2. So those are all the numbers that would fit this inequality. If it's an or statement, more often than not, it's going to split apart. So if we take those numbers, we got 0, we got -2, we got 1. Okay. Then x is less than -2, less than or equal to -2, which means we're going to go to the numbers that are less than -2, like -3, -4, -5. And on 1, x is greater than 1, it's going to be an open circle. We're going to go to the numbers that are bigger than 1, like 2, 3, 4, 5. Okay, so they're going to split apart. More often than not, if it's an or statement, they're going to split apart. If it's x in between two numbers, they're going to bridge together. Okay, you have $50 spent at a county fair. You spend $20 for admission. You want to play a game that costs $1.50. Describe the possible number of times you could play a game. So we're setting up an inequality, okay? And the most important, or one of the most parts, is you only have $50 to spend, okay? And you spend $20 for admission, and it costs $1.50 for each game. So I'd set this up as the $20 you have to spend for admission plus $1.50 per game. I'll just call that G. Okay, has to be less than or equal to the $50 you have total. Okay, so that would be a good scenario to, you have $20 but the $1.50 game has to be less than or equal to 50 because you don't have more than $50. You can spend 50, you can spend less than 50, but you can't spend over 50. After that, you're broke, you're done. So then if you simplify that, subtract 20 from each side for the admission from the $50 you had to spend, and you have $1.50 per game, which is less than or equal to, you have $30 left to spend on games. Okay. And then since it's $1.50 per game, you gotta divide that by $1.50. I know that's ugly. sign right there. Fix that. Okay. And then what's 30 divided by $1.50? It's 20. Okay. So G is less than or equal to 20 games. Okay. You can play 20 games or less if you have $50 to spend. Okay. That's the max amount of games you can play. And that was how you would set it up using an inequality. All right, so solving this equation, for the most part, what I would suggest doing is keeping your x on the left side. You can subtract 5x, but a lot of times when x is on the right side of the inequality sign, people get confused on which way. If the x is on the left side of the inequality sign, then the arrow will always point to which way you need to graph. So what I would do is subtract 7x first, and that give you negative 2x plus 2 is greater than negative 4. And then we just want to get x by itself, so we're going to subtract 2 from both sides and get negative 2x is greater than negative 6. And then the next step is to divide by negative 2. Now, if you remember from Algebra 1 and other classes, whenever you divide by negative 2, you have to flip the inequality sign. So it becomes x is less than 3. Okay. Whenever you divide or multiply by a negative, you have to flip the inequality sign. So it becomes from greater than to less than. All right. And then you can plot that. Let's give ourselves some room. X is less than 3. So we got 0, 1, 2, 3. You got 3. And it'll be an open circle on 3 going to the left. Now, they're saying any number less than 3 will make this true. Let's pick an easy number to plug it in and check it. Let's plug in 0, because that's less than 3. If I plug in 0, 5 times 0 is 0, plus 2 is 2. Is 2 greater than 7 times 0, which is 0, minus 4 is negative 4. Is 2 greater than negative 4? Yes, that does check out. Okay, that is correct. All right, so any number less than 3 is going to make this inequality work. So it does prove that when you divide by a negative, if you flip the sign, that you need to do that. All right, I'll let you try these on. Make sure you also graph. A lot of people solve and then forget to graph. Make sure you solve and graph those. And if you have questions in class, we can go over those. All right, compound inequality. Okay, the main thing is if there's a compound inequality x in a mill, you just want to get the x in a mill by itself. We've done this in Algebra 1. So you add 10 to both sides. And we have negative 4 plus 10, which is 6, is less than 6x minus 10, which is less than or equal to 24. Okay. Check that. That 10 shouldn't be there anymore because we added 10. We got rid of it. Okay, so it should just be 6x. 6 is less than 6x, which is less than or equal to 24. Then we're going to divide by 6 on both sides. And when 6 divided by 6 is 1, is less than x, is less than or equal to, we didn't divide that by 6. 24 divided by 6 is 4. So we'd have x's in between 1 and 4, basically, or x is greater than 1, but less than or equal to 4. So then we graph that. Start with 0 in the middle. You know, we got 1, 2, 3, 4, and we have 1. Okay. And remember, if x is in the middle, it's going to connect. Okay, so we got an open circle on 1 because there's no line underneath it. Then we have a closed circle on 4. And we're going to connect them because x has to be less than or equal to 4, like 3 and 2, and has to be greater than 1, which is 3 and 2, and any other number like 1.5. Okay. You can always plug it in, answer, check. Let's say if we plugged in 2 to see if it works. 2 times 6 is 12. 12 minus 10 is 2. So you'd have 2 is greater than negative 4. That works. And 2 is less than or equal to 14, which works. So that proves that it works. Any number between 1 and 4 will make that work. Okay, or it just means you're going to solve the first one over here, solve the second one here, and then graph them on the same inequality sign. So to solve the first one, we're going to subtract 5 from both sides, which gives us 3x is less than or equal to 11. And then we're going to divide by 3, which gives us x is less than or equal to, you can leave it as 11 thirds, but just for graphing purposes, we want to kind of know as a decimal what that is. It's actually 3.6 repeating. Okay. So 11 thirds, 3.6 speed, we at least know now it's between 3 and 4. Then the other one, we're going to solve that. We add 7 to both sides. So we have 5x is greater than or equal to 30. You know what? I messed that one up. Go back. Haven't made mistakes today. All right, so we go back. 11 minus 5 is 6. 6 divided by 3 is 2. So that should be x is less than or equal to 2. Sorry about that. Okay. Fixing mistakes. All right, so you add 7 to this one, you get 30. Then we're going to divide by 5, and we get x is greater than or equal to 6. Okay. Again, if it's an or statement, just put an or in between them, then they're probably going to split apart. So we graph our number line. We got 0. We got 2. We got 6. Okay. On 2, we have a closed circle, and x is less than, so we're going to go to the smaller numbers like 0 and 1 and negative. Okay. And on 6, it's a closed circle because we got an equal sign. So we're going to close it, and we're going to go to the bigger numbers like 7 and 8, 9, a million, whatever. Okay. But or statements usually split apart. Not always, but usually they're going to split apart. And statements are going to bridge together. Okay. So make sure that you solve and graph the solutions. All right, that's a compound one. I'll let you solve it on your own. It's very similar to the one we just did on the other page. Again, these are also, that's compounds, probably going to be bridged together. Notice how there's a negative there, so if you divide by -1, make sure you flip the signs. Or statement's probably going to split apart. Another or statement's probably going to split apart. Okay, so you have examples how to do this once you solve those in class and ask questions if you have them. Again, not sure about the book situation, so I'll let you know what your assignment is in class. And that is it.